In this question, we've been told that the variable x was measured to the nearest whole number. 40 observations are given in the table below. A histogram was drawn, and the bar representing 10 to 15 has a width of 2 centimeters and a height of 5 centimeters. We're then asked to find the width and the height for the class 16 to 18. As soon as we see any grouped interval table, the first thing we should be thinking about is whether or not there are gaps in between one interval and the next interval. Do we need to apply bounds? And in this case, yes, there's a big gap between 15 and 16 and then between 18 and 19. We need to use bounds. The other clue is that we're told that this was measured to the nearest whole number. If it's been measured to the nearest whole number, we're going to need to apply bounds to know what the original values might have been before we rounded to 10, before we rounded to 15, before we rounded to 16. So, to make sure that we get all of our marks in this question, we need to make use of bounds. So I'm going to get a visual representation of the bar that represents 10 to 15. Using the boundaries, we have 9.5 to 15.5. And now we're going to get the correct class width. The class width being the difference between these two numbers, that's 6. And the question told us this was drawn with a width of 2 centimeters. So a scale factor that links our class width with our drawn width is dividing by 3. Frequency density, we can calculate by taking the frequency and dividing by the class width. 15 divided by 6 in this case gets us 2.5. In the question, we were told that the bar was drawn with a height of 5 centimeters, so we recognize now the scale factor is to multiply by 2. The key here is to get these two scale factors, and we'll be able to apply them to any other bar we need to work with. The question has asked us to work with the bar for 16 to 18. The boundaries are 15.5 to 18.5. The class width in this case is going to be 3. And if we apply the scale factor, which is dividing by 3, I see that the drawn width must be 1 centimeter. Frequency density. This time round, we're going to have 9 divided by 3. That gets us an answer of 3. Apply our scale factor again. So this time we're multiplying by 2. The drawn height is going to be 6 centimeters. Okay. Part C of the question asks us to use an interpolation diagram to find an estimate for the median. Well, firstly, we need a cumulative frequency, which I'm just going to put here right on the table. The position of the median is going to be n divided by 2. So in this case, 40 divided by 2, the 20th value. The interval which contains the 20th value is this one here, 16 to 18. So we know the value is going to be somewhere in between 15.5 and 18.5. So, setting up a diagram, here's the boundaries. Cumulative frequencies would have taken us from 15, that's at the beginning of this interval, to the 24th value at the end of this interval. And we're interested in trying to locate the 20th value. So right here, the 20th value. Okay, we should now be able to set up a fraction equation, which we can go ahead and solve. So Q2 will be our subject. Q2 minus 15.5 over 18 minus 15.5 equals 20 over 15 minus 24 over 15. Simplifying as we go along, I haven't even touched my calculator. I know the calculation is going to be 3 times 5 over 9 plus 15.5. And that gets us an answer for our median of 17.17.